Hello, this is Walker Physics, 4th edition, and we're in Chapter 7 on work and kinetic energy. And this is the end of the chapter questions, question number 32. A spring with a force constant of 3.5 times 10 to the 4th newtons per meter is initially at its equilibrium length. How much work must you do to stretch the spring 0.05 meters? And how much work must you do to compress it 0.05 meters? Okay. Well, the second question and the first question have the same answer, because if you have a constant, that's the stiffness of the spring. So how stiff that spring is. So if you compress it, there's a certain resistance to compression, and if you stretch it, there's the same resistance to compression, or to stretch. So whatever it happens to be, when we find out what it is, it'll be the same. Okay, you're doing work, you're moving at a distance, either stretching it, or you're moving at a distance, compressing it, and that displacement is in the same direction as the force. So it takes just as much work, whatever that happens to be. Okay, so A is asking us to how much. So we need to use the spring constant. So Hooke's law, remember, is either kinetic energy or work, it's the same, is equal to 1/2 times the constant, the spring constant, how stiff it is, and we find that that's what the spring constant is, times the square of the displacement, either the square of the compression or the stretch. All right, so this is going to be 1/2 times 3.5 times 10 to the 4th newtons per meter times 0.05 meters. We have to square that. Okay, so 0.05 squared times 3.5 times 10 to the 4th equals, divided by 2 equals, we get 43.75 joules. And we're in two significant digits here, so this would be 44 joules. And then how much to stretch it? 44 joules. Okay, so A is going to be 44 and B also is 44. We're just moving in the other direction, that's all. Okay, thank you.